Welcome to today's Explainer. I am honestly so excited to have you here today because we are tackling one of the absolute most fascinating challenges in artificial intelligence right now. We're going to explore a really groundbreaking technique designed to bridge the gap between our complex human intuition and rigid AI logic. It's all about teaching machines not just to process our words, but to actually understand our perspectives.
Okay, let's dive into this. It sounds a little like science fiction, right? We're asking the big question today. Can an AI truly read your mind? Or, well, more accurately, can it understand your thoughts, your intentions, and your specific point of view in any given situation? It is a massive hurdle that developers have been trying to clear for years.
To understand why this is so tricky for AI, we kind of have to understand ourselves first. There's this concept called theory of mind. It's basically the uniquely human ability to naturally intuit thoughts, desires, and intentions. It's how we predict or explain someone's actions just by watching their behavior. You and I do this effortless social reasoning every single day, usually without even realizing we're doing it. We just instinctively know what someone else might be thinking based on what they've seen or experienced.
So here is our roadmap for the explainer today. First, we'll look at the theory of mind problem. Second, we'll introduce SimToM prompting. Third, we'll break down its two-stage process. Fourth, we'll run the coffee shop test. And finally, we'll cover its limitations and the future.
Let's start with Section 1, the theory of mind problem, and exactly why AI struggles with perspective.
Now, we know this sort of thinking is second nature to us, but why is it so incredibly difficult for even the most capable, hyper-advanced large language models? Well, the root of the problem is right here. AI takes all information literally, and it takes it all in at once. When an AI reads a story or a prompt, it basically has a godlike view of the text. It knows everything that happened everywhere, and because of that, it deeply struggles to filter context based on what an individual character actually knows. These models just lack that innate human ability to easily filter out irrelevant information or separate different characters' isolated perspectives. Which brings us to Section 2, introducing SimToM prompting and the use of simulation theory in prompting.
Now, what's really interesting about this slide is where the name actually comes from. Think of SimToM as handing the AI a pair of perspective-taking glasses that helps it see through a specific character's eyes. It draws from simulation theory, which suggests that what people perceive as reality is actually a simulated world, and that humans themselves are constructs. So by applying this to AI, SimToM treats human perspectives within a text as distinct, simulated constructs. It forces the AI to step into that specific simulation rather than looking at the whole world from the outside.
And honestly, the advantages of this framework are a real game changer. By stepping into that simulation, SimToM actively eliminates the effect of all that irrelevant information in the prompt. And what's even better for you and me is that it requires absolutely no additional expensive training for the model. It needs only minimal prompt tuning to get up and running. Most impressively, the tests show that it consistently outperforms older, highly popular prompting methods like zero-shot and chain of thought when it comes to these specific theory of mind benchmarks.
Moving right along to Section 3, the two-stage process, where we'll deconstruct how SimToM actually works.
So how exactly do we solve this? How do you implement these perspective-taking glasses? It comes down to a very specific, structured approach. SimToM relies on a rigid two-stage process, and you really cannot skip these steps. Stage 1 is perspective-taking. Before the AI is allowed to answer any questions at all, you prompt it to filter the context based purely on what a specific character knows. You literally tell the AI, hey, which events does this character actually know about? Then, only after the AI has isolated that character's knowledge do you move to Stage 2, question answering. Now you ask the AI to answer a question about the character's mental state using only the filtered story from Stage 1.
Let's look at Section 4, the coffee shop test, so we can see SimToM in action.
I know the mechanics can sound a bit abstract, so let's see this two-stage process work in a real-world demonstration. Let's set the stage with a quick story. Noor is working as a barista at a super busy coffee shop. She wants to make a cappuccino for a customer who asked for oat milk. She fills the pitcher with oat milk, but a coworker, who clearly wasn't paying attention, swaps it out for almond milk. Now, crucially, Noor sees this swap happen. So here is the crucial test question that requires theory of mind. Based on that story, does Noor believe the milk pitcher contains oat milk or almond milk? To get this right, the AI has to adopt Noor's specific perspective and understand exactly what she witnessed. And this brilliantly illustrates the power of SimToM. Just look at what happens when asked normally. The standard prompt AI gets completely tangled up.
It says Noor believes the pitcher contains oat milk, but then literally in the same breath contradicts itself by saying she's aware it contains a different type. It completely fumbles the character's perspective. But notice the SimToM AI down there. Because we use that two-stage process to filter Noor's knowledge first, the output is perfectly clear. It even speaks beautifully from her perspective, saying, I believe that the milk pitcher now contains almond milk, not oat milk as I had originally prepared. It flawlessly passed the theory of mind test.
Finally, Section 5, Limitations and the Future, where we'll set the boundaries for SimToM.
As amazing as that last example is, we do need to ground ourselves with some realistic boundaries, starting with the model's baseline capabilities. There's a very specific sweet spot for this. If you are using a massive, highly advanced model that is already perfect at theory of mind questions, well, SimToM isn't really needed. On the flip side, if you're using a model that is completely broken and can't reason at all, SimToM isn't some magic wand, it's not going to help. The sweet spot is when a model fails the test initially, but clearly has underlying reasoning potential, just like the AI in our coffee shop test. That is where SimToM steps in and perfectly fixes the output.
There are also some hard technical boundaries you should definitely be aware of. SimToM has primarily been tested on datasets that require hiding parts of an original story from a character. Because of that, it might actually struggle if the reasoning requires the AI to guess or impute unseen information. Also, as a strict rule, SimToM has not been tested on smaller language models. If you try this on a model with less than 7 billion parameters, the tool is likely going to break.
But even with those boundaries, what we are looking at is a massive step forward. By overcoming these limitations and giving AI a better theory of mind, SimToM paves the way for much more sophisticated human-machine interactions. We're talking about highly personalized assistants that actually get your context, intuitive learning aids that can adapt to a student's confusion, and honestly, just far more empathetic user interfaces overall.
Which leaves us with this final thought. As techniques like SimToM continue to evolve, we are moving so rapidly away from machines that just crunch text and toward machines that can truly understand our perspectives. So I leave you with this question to ponder. As this technology gets better at reading human intentions, how will empathetic AI change your daily life? Thank you so much for joining me for this explainer today. Keep exploring, keep learning, and I'll see you next time.